About 20,000 years ago, the Earth reached the peak of the last glacial maximum. Now, this wasn't just some colder winter, it was a complete planetary metamorphosis. Colossal ice sheets gripped the northern hemisphere, stretching from the heart of North America across northern Europe. These weren't just simple glaciers, they were monolithic walls of frozen water, built up over thousands of years of snow compacting under its own crushing weight. To really grasp the scale, just think about this. Permanent ice covered nearly 2.5 times more of the planet's surface 20,000 years ago than it does today. In our current world, permanent ice is a footnote, covering barely 3% of the surface and less than 10% of the land. The geographic contrast is just staggering. How did a hairless, vulnerable primate not just survive, but actually thrive when the world turned into a frozen wasteland? On average, the global temperature sat about 6 degrees lower than it is today. But as it turns out, this freeze was far from uniform. The cold was a jagged, uneven force. In the Alps, the air was consistently 10 to 12 degrees colder, while in the Arctic, the average temperature plummeted a staggering 14 degrees below modern levels. Two giants dominated the northern landscape. The Laurentide ice sheet blanketed North America, stretching from the Arctic all the way down to the latitudes of New York City, piling up into a frozen slab nearly 4 kilometers thick. In northern Europe, the Fennoscandian ice sheet carved the land from the British Isles to northwest Siberia, pushing south into northern Germany and Poland with thicknesses reaching 3 kilometers. Beyond these titans, the world was studded with smaller, frozen caps. Glaciers clung to the Pyrenees, the Carpathians, the Caucasus, the Tibetan Plateau, the Himalayas, and even the remote reaches of Tasmania and southern New Zealand. Ice caps sat heavy on Iceland, and smaller glaciers even formed on islands like Corsica. It's honestly difficult to wrap your head around ice that deep, literally burying the equivalent of the world's tallest skyscrapers. Now, visualize the oceans receding, pulling back like a giant curtain. During the last glacial maximum, sea levels dropped by 120 meters. This happened because roughly 50 million cubic kilometers of water were locked away as ice on the continents. This wasn't a subtle shift. It was a total redrawing of the global map. If you were standing on the floor of a vanished sea, you could actually walk from northern Europe to the British Isles. In the east, the Sea of Japan closed, connecting the Japanese archipelago to Korea and China via the dried-up Yellow Sea. Sri Lanka merged with the Indian subcontinent, and the Persian Gulf vanished entirely, allowing travelers to cross it on foot. Further south, the tip of the Arabian Peninsula fused with the Horn of Africa, turning the Red Sea into a massive salt lake. The Black Sea shrank dramatically, severed from the Mediterranean. In Europe, eastern Italy connected to the Balkans, and southern Greece fused with Turkey. Across the Atlantic, the Florida Peninsula and the Yucatan were roughly twice as large as they are today, while Caribbean islands expanded and new ones emerged. In the southern hemisphere, Argentina's east coast pushed out by nearly 200 kilometers in some areas. Even the most remote corners were reshaped. The Ciudad Mala Bank in the Indian Ocean was a group of low-lying islands the size of Cuba. The two main islands of New Zealand became one. And the ice didn't just claim the north. A layer of ice covered the majority of the Andes from Peru to Patagonia, eventually connecting with Antarctica. During winter, massive stretches of sea ice covered high latitudes, making it theoretically possible to walk from Ireland to North America, or from southern Patagonia to Antarctica, across frozen oceans. One might assume a world of ice is a world of water, but the reality was a paradox. A severe drought prevailed almost everywhere on land. It wasn't just cold, it was bone dry. The massive inland ice sheets caused temperature, evaporation rates, and humidity to plummet at high latitudes, essentially locking the moisture away in frozen sheets. Because the sea receded, the distance between shorelines and inland areas increased, making rainfall a rarity. The interiors of continents became vast, arid corridors. In Western Europe, this atmospheric instability meant the land was frequently swept by gigantic sand and dust storms of a magnitude that would be unrecognizable today. It's a gritty, harsh reality, a world where the horizon was often obscured by clouds of grit and wind-blown soil, turning the frozen landscape into a desert of ice and dust. While the northern hemisphere was locked in ice, the other side of the planet was opening new paths for our ancestors. In Southeast Asia, the landmasses of Borneo and Java merged with the mainland, creating a vast, sunken plain called Sundaland. This region was a biological powerhouse, containing the largest tropical rainforest in the world at the time, sliced through by a central savanna corridor. It is believed that the first sapiens took the route through Sundaland to reach Sahul, a single continuous landmass formed by the connected territories of Australia, Tasmania, and New Guinea. This journey was a testament to cognitive flexibility. This is where we stop being just another animal and start becoming the architects of our own survival, using planning and symbolic storytelling to cross oceans and settle new worlds. But there is a hidden key to this expansion: the shift from simply hunting animals to the high-risk strategy of scavenging carrion, which provided the same calories with less danger. That transition changed everything about how we survived the deep freeze. Let's look at the tools that actually kept us alive. To survive the deep freeze, our ancestors didn't rely on luck. They engineered a specific kind of warmth. The most critical piece of technology was the bone needle. These weren't simple pins, but precise instruments carved from the bone of foxes and hares. Using these, early humans moved past the crude draped capes of the Neanderthals to create truly tailored fur clothing. This wasn't just a change in fashion, it was a portable thermal protection system. This is where the cognitive leap happened. The ability to create a tailored fit prevents heat loss up to 90% more effectively than a loose wrap. A single needle allowed for a stitched, windproof barrier between the skin and the killing cold. These needles were used to create complex layers of windproof gear and insulated boots. In some regions, researchers have even found needles made from the bones of the extinct American cheetah. This detail is crucial because it demonstrates that our ancestors were utilizing every single scrap of the animals they hunted. In Sahul, however, the challenge wasn't just the cold, but an unforgiving landscape. Evidence shows that Sahul was a vast desert, half of it covered by shifting sand dunes, which required a different set of survival tools for water conservation and navigation. It was a move from opportunistic survival to an intentional, structured strategy of adaptation. Survival in this era wasn't a passive struggle. It was a high-stakes game of tactical precision. Take the site of Cameron Grubgraben in Germany. Here we find evidence of specialized reindeer hunting that reveals a staggering level of planning. Our ancestors didn't just stumble upon herds, they analyzed migration patterns, identified natural bottlenecks in the landscape, and coordinated their movements to drive animals into kill zones. This was an exercise in collective intelligence, requiring an understanding of animal behavior that borders on the intuitive. However, when the herds failed or the winter grew too lean, the strategy shifted to something far more visceral: scavenging. While hunting a mammoth is a feat of strength, scavenging a carcass is a feat of patience and risk management. Sapiens began to strategically time their arrival at carcasses, often waiting for the primary predator to finish before moving in. This high-risk, high-reward strategy provided massive calorie dumps, pure fat and protein, without the energy expenditure of a long hunt. It was the caloric fuel that allowed the human brain to maintain its demanding energy requirements in a world where every single calorie was a victory. What strikes me most about this is what archaeologists call the broad-spectrum revolution. It's a fascinating pivot. For a long time, humans were obsessed with the big game, the mammoths and the reindeer. But desperation is a powerful catalyst for innovation. As the climate fluctuated, our ancestors stopped looking only at the horizon for giants and started looking at the ground and the water. In Croatia, for instance, we see evidence of early humans pivoting to freshwater fish. It seems like a small change, but it was a revolutionary act of diversification. By expanding their diet to include fish, mollusks, and small game, humans created a safety net. The irony is that the harshest times actually forced us to become smarter eaters. We stopped being specialists who relied on one or two species and became generalists who could extract calories from almost anything the environment offered. This dietary flexibility was just as important as the bone needle. It was the biological insurance policy that kept us from extinction. It's a common mistake to view the Ice Age as a monolithic block of white. In reality, it was a mosaic of survival. While the North was a frozen wasteland, there were refugia, pockets of the planet that remained relatively hospitable. In the southeastern United States, for example, the climate remained mild enough to support diverse forests and wildlife, serving as a biological sanctuary where species could wait out the deep freeze. And the cold didn't always stop humans from climbing. In Australia, the Dargan shelter provides a startling counter-narrative. Evidence shows that humans were occupying high-altitude sites during the glacial maximum. This defies the simple logic that humans always fled to the warmest valleys. Instead, it suggests a sophisticated understanding of the landscape, perhaps tracking specific prey or utilizing high ground for visibility. It shows that our ancestors weren't just reacting to the cold, they were actively negotiating with it, choosing where to live based on a complex set of needs, rather than just a search for warmth. We often think of the Ice Age as a permanent state, but it was actually a fragile equilibrium. The most shocking part of this entire era is the blink of an eye transition. A mere 4 to 5 degree shift in global average temperature is the difference between our modern world of lush forests and a world where 4-kilometer thick ice sheets bury New York and the mammoth steppe dominates the globe. Think about that scale. A few degrees of warmth didn't just melt some ice, it triggered a systemic collapse of an entire planetary ecosystem. The mammoth steppe, that endless, fertile ocean of grass, didn't just fade away, it was replaced by forests and tundra in a geological heartbeat. This shows us that the Earth is not a static backdrop, but a dynamic system where a tiny nudge in temperature can redraw the map of the world and erase the biological bridges our ancestors walked upon. This leads to a haunting question about our cousins, the Neanderthals. They were stronger, had larger brains, and had survived in Europe for hundreds of thousands of years. So why did they vanish while we endured? Some argue it was a lack of cognitive flexibility, but the evidence points toward diet. Neanderthals were opportunistic hunters. They focused heavily on large gain. When the climate shifted violently and the big herds dwindled, their specialized strategy became a liability. Sapiens, on the other hand, had already embraced the broad-spectrum revolution. We were eating fish, birds, and small tubers. The thing is, while the Neanderthals were waiting for a mammoth that never came, sapiens were finding calories in the mud and the stream. Did the Neanderthals' refusal or inability to diversify their diet seal their fate? It's a tension that remains one of the greatest mysteries of our prehistory. Our current world feels permanent, but the last glacial maximum reminds us that the Earth is a shapeshifter. Just a 4 to 5 degree shift in temperature is the difference between our modern forests and a world of mammoth steppes and 4-kilometer thick ice sheets burying New York. We see the ghost of this era in the 120-meter rise of the sea levels that drowned Sunderland and Sahul, erasing the bridges our ancestors walked. We survived not because we were the strongest, but because we could turn a fox bone into a needle and a scavenged carcass into a calorie-dense lifeline. The question that remains is whether we recognize the fragility of our own climate balance. If the map of the world can be redrawn so violently by a few degrees of cold, what happens when the map begins to shift again?